Algebra 1, Chapter 3.4, we're going to talk about direct variation, using slope, certain types of equations, and this is a very specific type of equation. Direct variation, guys, is an equation of the form y equals kx, as we have it stated. The really cool thing is that, or something about it, is k cannot equal 0, because if k equals 0, that'd be 0 times x, and anything times 0 is 0. You would never have anything more than just 0 for an answer. So we can't let k equal 0. That doesn't work. So it can be anything but 0. We call that a constant rate of change. It's a constant rate of change for all direct variation equations. That means the constant of variation, the graph is linear and it won't change. No matter what 2 points I choose on the certain graph of this direct variation, you will find the rate of change, delta y over delta x, or the slope formula will be the exact same. That's what it means. We also should know, because I'll be talking about it, you need to sometimes find k. We need to establish what k is. K is what we call the constant of variation, or the constant of proportionality. So one of two things. So let's go into some examples of slope and constant of variation. For this example, I want you to name the constant of variation for each equation. And then I want you to find the slope of the line that passes through each pair of points. I'll do part A together. Part B you guys will do on your own before we come together. You should start to recognize some things. Now, one of the first things you will see is a set of points. And then there's the equation after it, which is direct variation, y equals 1/4 x. Those points satisfy that equation. Can you guys agree? If I put x is 0 in, 0 times 1/4 is 0. So 0, 0 definitely works. If I put 4 in, 4 times 1/4. What's 4 times 1/4? It's 1. And so the point 4, 1 also works. We kind of verify at least the points are on the line. So if I graph those two points, I will have a line. So the first part it wants you to do is name the constant of variation. K. What's K? K is what in this equation? Yeah, what is it? There's your equation. What's K? 1/4. Oh, it's 1/4. And then it says, find the slope between those 2 points. I think everybody can do that. We just need the slope formula, right? What's the slope formula again? Everybody should know this. M equals correct. y2 minus y1 divided by x2 minus x1. The other thing I wanted you guys to do is actually mark which one's x1, y1, x1, x2, y2. So if I go back up here, is it okay to call this one x1, y1 for 0, 0? The next point is x2, y2. Doesn't matter though. It will not matter what order you go in as long as you keep it consistent. It's the change in y's over the change in x's. If we're putting the x's over the y's still, there's a problem. We spent a lot of time doing slope and rate of change. M equals, what's y2? 1 minus over 4 minus. Ooh, that's easy. 1/4. The slope is 1/4. The constant of variation is are the same. So the constant variation actually tells us the slope. But you need to verify that. I'm going to give you guys a couple seconds to do part B. What's the constant variation? K is equal to -2. Why? Because it's in front of the x right there. It's -2. That is a -2. Then, going with slope again. Guess what I'm writing down again? Slope formula. Hey guys, I'm going to be fun. And I'm going to say this is x1, y1. And I'm going to put 0, 0 as x2, y2. Is that what everybody else did? Probably not. But what's y2? According to mine. 0. Minus y1? 0. -2 over 0 is x2 minus 1. When I subtract a negative, I am adding. So I get 2 over -1, which is, and again, they are the same. That's what we're trying to highlight there, okay? Any questions? Yes? So, what did we learn? K is the slope. Graphs will always pass through Let's go back here. If I look at this equation, okay, I'll change here. Y equals kx. And k can be anything, right? 1, 2, 3, 1.25, -1.25, things like that, right? But x can also be anything. Which number, no matter what k value is, will always give me the same result out? Not 1, because if it's k is 2, the output will be different. 0. Think of this, guys. No matter what k is, k times 0 is equal to, so the point 0, 0 is always a solution to a direct variation equation. Can you guys agree with this? So therefore, the graphs will always pass through 0, 0, because 0, 0 is always a solution to the line. Pretty cool stuff. So let's graph these things. Well, I basically told you what? Every single one of these graphs will pass through what? 0, 0. But, hey guys, we have two methods, I think, for actually graphing this. Or one method that you know already. That is, anytime I am approached with a new equation and I have to graph it, you should create a table. So, let's make a table. X, Y, with a 2/3 X. Right? So let's just put values in. Hey, we told you zeros should be what? We just said this one. 0 should give us what? 0. It should be 0. Does it make sense? 2/3 times 0 is 0. Okay, so 0, 0 is definitely one of them. Let's choose another one, like 1. 2/3 times 1 is 2/3. Ooh, put 2 in. That's 2/3 times 2, which is what? How many? It's not 2/3. 2 2/3 makes, if I go like this, guys, put a 2 over 1. It's multiplying fractions. How do you multiply fractions? Top to tops, bottom to bottoms, right? 2 times 2? 1 times 3? So it gives 4/3. Man, those are not so nice numbers, are they? Let's go with 3. 2/3 times 3. Yeah, it's 6/3, right? Wait a minute, 6/3? It's 2. That's nice. Hey, do we have enough numbers now to probably graph that? We do. I'm going to go right in the way here of this guy. Okay. 1, 2, 3, 1, 2, 3. 0, 0 is one of them. Another one was 1 and 2/3? 1 and 2/3. Somewhere about there, yeah. Give or take. 2 and 4/3. A little above 1. And then 3 gave us 2. It's not so bad. I can make a table. I can put the values on a graph and draw a line. It looks pretty good, right? What if I said there was an easier way to do this? That would give us a lot better line. That would be pretty cool. Guys, let's go back and talk about this. The fact that I said 2/3, which is the constant of variation, is also the what? What is that called? Or what can we also call it? The slope. The rate of change of that line. So let me ask you this, guys, because we did this exercise. If I went here and I said, what's the rate of change between those two spots? What's it going to be? It's going to be 2/3. Can you guys agree with this? Because the rate of change is 2/3. Would you agree that, I'm going to extend this red line. Would you agree that that next one is also 2/3? Whoops. What's that one? 2/3. What is this one? It's 2/3. They're all going to be 2/3. Doesn't matter where I start, where I stop. The constant of the rate of change is constant. We showed that when we had our lines, and some people made larger triangles, some people made smaller triangles, but the ratio still came out the same. Right? So here's the thing. What if I use this ratio, this slope of rise over run? You guys remember that? We talked about rise over run. What if I use that to my advantage? What if I said, if I was given just a single point on this graph and the slope, I can make a line. I'm going to try backing out all the blue. Okay. And watch this. I'll change the purple. If I started at 0, 0, because we knew 0, 0 was on this line. It's on all direct variation lines, yes? And I decided to use slope to my advantage. We said slope, m equals 2/3. What if I called that my rise over my run? So what does this mean? This means I am going to go up 2 and then over 3. That's slope. That's the ratio of 2 to 3. Here's you go. I'm going to start here at 0, 0. I'm going to go up 2. 1, 2. And then I'm going to go a run of positive 3. 1, 2, 3. So I went up 2 over 3. There I am. I'm going to go 1, 2, up 2 again. 1, 2, 1, oops. 1, 2, 3. There's another point on the line. Guys, guess what? This is a really cool thing. Would you guys agree that negative 2 divided by negative 3 is also a positive 2/3? So if I use negative 2 over negative 3 as my rise over run, I'm not actually rising, I'm falling 2, but not going in a positive direction on the run. I'm actually backing up. So watch this one. Now I am going to go down. I'll start here. If I go down 1, 2, and back 1, 2, 3, I'm right about where that S is, right?
Right.
Oops. About there. And guess what, guys? All of those are in a straight line. So, this is what I want to do. I want to start with 1 point on direct variation. What point do you think I want to start with? 0, 0. They're all 0, 0 on a direct variation. Y equals kx. Then, I'm just going to find that constant, because of the equation, that constant of variation, and I'm going to use it as slope, rise over run. Guys, I want it once in the forward direction, which means moving to the right, and once going in the reverse direction, moving to the left. So that way I see you use slope twice. 2 points form a line. The third point is like that extra check to say, am I actually following a right pattern? Okay? I'm going to have you guys do part B. I'll tell you this, and I've been saying this for a while now. Slope as a blank is your friend.
Slope as a fraction.
As a fraction. Why?
Because it's already...
Because now you then have a rise over run. Is negative 5 a fraction right now?
Not right now.
You can change it. I'll let you guys try to figure that out. So, I ended before the break here with saying we don't want just negative 5, we want negative 5 over 1. So maybe write that m equals negative 5 over 1, because that is my rise over run. So if I was going to graph it, what do I do? Well, yes, make a graph. Luke. Okay, made a graph. Who's going to pick it up now and go from here? Chuck.
So, if you go down 5 or up 5.
I don't know if I can do that yet.
Yeah, well,
Also, guys, because we're not using graph paper,
0.
my graph, I just really made this a little messy, but I would make all of your tick marks or your intervals as closely spaced as possible. So go on. What's that?
Start at 0, 0.
Okay, number 1, put a point at 0, 0. That's your starting point. Okay, someone else now pick up. Abby.
Okay, so now I go down 5 and then go 1
Which way?
left.
Let's think of this. The negative is on the 5, so that means the rise will be going down. Why am I going to the right? Because it's a positive one. Okay? So the negative is on the 5 right now, so therefore I will move down. The 1 is positive, so I run positive x. So I move 1, 2, 3, 4, and I need more, right? Boom. So you will be here. I also want you to do what?
-2,000.
Go in the opposite direction, which means make the top and bottom negative, but maybe that's not the right word because they both won't be negative, will they?
No.
That means basically take the negative and move it from the top and move it to the bottom. So now we should also recognize that that would also be 5 over -1. That would be the same thing. But if it's 5 over -1 now, I will move which way?
Left.
Gotta be careful. Go up 5 first and then
Then
left 1. So 1, 2, 3, 4, 5, and back 1. And that was bad. Better. And there's your line. Hey guys, wait. I erased the first one. You can see a little bit of it yet. Here, this was a 2/3 slope, which was a positive slope. The line went up.
it was into the right.
It was increasing. This graph has a negative constant of variation, negative slope, so it is going down or falling, decreasing. Some connections from earlier times, yes? So let's talk about the equation part of it. Because not always are they just going to give you this direct variation equation. They're going to have you write the equation. And so, obviously, we can see this is the exact same information up front that I told you earlier, that it is the direct variation equation of y equals kx and k can't equal 0. Yeah. We also say that it has a positive slope if k is greater than 0. Hey, we just talked about that. And negative slope if it's less than 0. We just highlighted that with our last two problems. Great. The biggest thing now, guys, is the wording underneath that box. If the relationship, it says, between x and y can be described as direct variation, then we can say y varies directly as x. So if we're saying that we have a direct variation equation, you would say y varies directly as x. That means if x goes up, y goes up. If x goes down,
Y goes down.
y goes down. It's as easy as that. They're directly related.
Direct correlation.
Direct correlation. Nice. So let's talk about an equation, an example. This example, using the fact that y varies directly as x, says write and solve a direct variation equation. I want you to write the equation, and once you have an equation, I want you to use it to find something else. Your example, it tells you y varies directly with x. As soon as I see that, I should be writing this down. Y equals kx. That's your direct variation equation, right? Okay, so y varies directly with x. And y is equal to 98 when x is 14. Wait, it tells us an x and a y? What do you think we can do then? What's the only thing that didn't give us? The slope, or k.
Okay.
If I know x and I know y, can I find k? Yes. So it says write the direct variation equation that relates x and y. Then, once you know that equation, can you find y if you changed y to negative, or x to -4? So let's take it one step at a time. It tells us again, y varies directly as x. Boom, y equals kx. It tells us y equals 98 with x equals 14. Plug them in, guys. 98 equals k times 14. Can you solve for x? Divide both sides by 14. We should be past that point. Boom. K is equal to 7. So we just wrote our equation, right? No, we did not write our equation. We found K, or the constant, aka the slope. We did not write the equation. The equation, guys, is y equals kx. So what I'm going to do with k, or 7, to write the equation, I got to take k out and write it with its value. That is part 1. Write the equation. Everybody do that? I think so. Simple substitution, solve for k, then substitute k back into that equation you wrote down originally of y equals kx. From here, guys, we can solve for x or y if I'm given x or y anytime. In this case, find y if I let x equal -4. So y equals 7 times -4, and 7 times -4 is -28. We need both of those pieces to satisfy this problem. Y equals 7x is the equation. Y equals -28 when x is -4 is the answer. Questions? We like that? Last problem wants us to estimate using direct variation. So you guys are going to have to do the exact same thing you just did on the last page. We're also going to graph it and then use it to predict the future or something that's going to happen later. Kind of rolls everything into one. Guys, it says the distance a jet travels varies directly as the number of hours it flies. A jet traveled 3,420 miles in 6 hours. A, write a direct variation equation for the distance flown, distance D, I forgot to put that on there. For the distance, the distance, we'll use D, flown in time T. Then I want you to graph it. Stop there for now, and then we're going to predict. So I'll let you guys try this on your own first. Okay. Who's got this idea of what we should do for the equation? What's the first thing that pops into your mind? School related. Math related.
For what?
What do you read? What's the first sentence in there?
I don't read anything.
The distance a jet travels varies directly as the number of...
Boom. Varies directly. What are you going to write down?
I'm going to say that distance...
D equals KT. Why am I using D and T instead of X and Y?
Because D for distance.
D for the distance and T for time. Distance equals rate times time. What do you think K is actually representing? The rate of your plane. Interesting how this all comes together. That's not the equation, guys. That is the generic form of it. We need to solve for K. What should I do now? Plug in 6 hours for T. And the distance is 3,420. What will be done next? Someone who doesn't answer all the time. Yes, Aaron.
Divide both sides by 6.
Divide both sides by 6. So K will equal then, what's 3,420 divided by 6, Joe? Oh. Carson. If we were just listening, we would just heard 570. So, It's 570. Technically, it's miles per hour because you're dividing distance, miles, divided by time. The plane is traveling 570 miles per hour. Guys, what's the equation though? D equals 570 T. Can we graph this? Hours go across the bottom. 1, 2, 3, 4. Going by ones. What do you think I probably should use my Y or the D axis? Probably go by 500s? 500s is fine. It's not going to be perfect, is it? But hey, wait a minute. We know what point's on here. What point guaranteed to be on here? 0, 0. It's on every single direct variation equation, right? I'll change colors so you guys can see that. And, wait a minute. 570, I can use that as slope. It's 570 over 1. Now, let's ask ourselves, would it be a good idea to use this once in the forward direction and then once in the backwards direction? Why would that not necessarily make sense for this particular problem?
Because you can't go like a negative.
Right, we're not going to talk about going negative times or negative distances, at least for now. Maybe some problems have to set you up and find out where were you 2 hours ago. But in this case, it's not. Look at part C. Estimate when you're going to fly 6,500 miles. That's in the future, isn't it? So, if I use slope as 570 over 1, I think everybody would agree that I'd be just over 500. Yeah?
Yes.
Then I can go rise over run again, which means I go up 570 miles in over 1 hour. So I go from here, just up past the line and over to there, right?
Right.
I like it.
And then I could do it again,
That's crazy.
and do it again, and again, and again. But basically, I'd form this line. First of all, guys, our graph pretty much only goes up to about 2,000 right here, right? Part C wants to know, how long would it take me to fly 6,500 miles? So, using the graph, is that a good idea? I mean, I could say, hey, I could have asked, hey guys, how about how long will it take me to go about 2,000 miles? That wouldn't be too bad. I just take 2,000, run it straight across, intercept, and fall down here. I would say maybe about 3 hours, 45 minutes. 3.75. It could be right, it could be wrong. This is a graph. So better option, guys, is use the equation we built. Where do you think 6,500 miles should go? And the part for D, distance. 6,500 equals 570 T. Can you solve for T? I would hope so. And when you do solve for T, you divide both sides by 570, more than 100. And you end up with T equaling, it says estimate, so obviously it might not come up to something nice. 11.4? 11.4 hours. Is that everybody else got? Is anybody going to check Matt? Okay, guys, is there any questions on this? It's pretty straightforward, I think, but it takes the practice. You need to practice this stuff. Homework is on page 185, 10 through 37. Have a great day.